4K quantum satellites revealed port structures over Antarctica. Do you know about quantum satellites? If not, we are going to tell you first about it. Satellites can be used to connect local ground-based quantum networks over vast distances as part of a broader quantum network design. Connecting networks in this manner would result in a network of networks similar to today's internet. Satellites provide a near-term solution for establishing a global quantum network. So before we move on to our video, I would like to ask you all to subscribe to my channel so you can get all the latest video notifications. Let's get started now. The frozen landmass of Antarctica is the continent of our planet about which we know the least. As part of their research, scientists are now using satellite imagery to look into the tectonics of the Earth and expose the hidden structures of Antarctica. Because of the remoteness and harsh environmental circumstances that limit direct geological survey in Antarctica, satellite remote sensing photography is particularly helpful for geological investigations. Charting Antarctica's geological features is challenging because of its remote location and abundance of ice. But the gravity field and steady-state ocean circulation explorer satellite can see what other satellites can't by precisely measuring the Earth's gravitational pull to map out hidden terrain. In 2013, GOCE ran out of fuel and dropped out of orbit, but scientists are still analyzing the data it gathered. According to the researchers, it provides a fresh understanding of how plate tectonics works and how Antarctica was formed. According to the British Antarctic Survey, one of its team members says, "We observe an interesting mosaic of geological characteristics in East Antarctica that highlight key similarities and contrasts between the crust underlying Antarctica and other continents it was related to until 160 million years ago." Antarctica was originally a part of supercontinent Gondwana, which started to break apart about 130 million years ago. The researchers were able to produce 3D maps of Earth's lithosphere, which is made up of the crust and the molten mantle beneath, by fusing GOCE readings with seismological data. The remnants of former continents set in modern continents are known as cratons, and they contain mountain ranges, ocean backs, and rocky regions. According to one of the researchers, Jörg Ebbing, from Kiel University in Germany, the satellite gravity data can be combined with seismological data to produce more consistent images of the crust and upper mantle in 3D, which is crucial to understand how plate tectonics and deep mantle dynamics interact. Among other things, the new research showed that West Antarctica has a thinner crust and lithosphere than East Antarctica, which has a mosaic of older cratons and thinner rock sections similar to India and Australia, to which it was once connected. Predicting how ice melt might spread across Antarctica with so many factors to take into account is a great problem, so any assistance scientists can obtain will be appreciated. And the data may be used for more than just tracing the remains of old continents over the last 200 million years, and it can also be used to predict how ice sheets above the underlying topography will react to warming temperatures. There's a small valley out here on the far side of Antarctica that, when we looked into it with Google Earth Pro, it revealed some very interesting structures and also evidence that forces are manipulating the imagery that don't want you to see things. But they can't hide everything when you use time, historical layers, and perspective. And it's almost impossible for them to hide things in every single year at this time. Despite the fact that a broad mountain range passes through this location, there is a valley and a structure right here that moves out to sea. We must assume that if this civilization was advanced enough to have survived the apocalypse down here, they were also likely advanced enough to navigate not only the surface waters, but also the seas beneath them. We discover another cable piece, one of the uncommon ones that go from 0 to 180. The majority of them travel between 90 and 270. Antarctica, this is it. We found 3 or 4 going perpendicular to this, and it's near right at the edge of this mountain complex, what looks like a very large tunnel structure. The fact that these all run at the same time is a dead giveaway. We mean not even a fraction off from 0 to 360, 0 to 180, or 90 to 270. And as they trace this, sure enough, it crosses one of these surface events, which is difficult to describe until you see it for yourself. These cross-hatchings indicate that there is something beneath in a grid pattern of some kind that is melting snow in some spots and not melting it in others, resulting in this blocking effect on the surface. Miles of snow are a terrific canvas for showing any faults. For example, you can look at a grassy field and not see the imperfections, but when the snow covers it, you can see every single rise and fall and hill and valley, simply because of the nature of how snow functions. And it's a bit strange to read a report that claims that very little snow falls down here and there's plenty of snow already existing, but very little fresh snow. But as you can see, this becomes more apparent as you travel away from structure, which is a little unusual. But we also see evidence on the other side for this exact thing. So we may be looking at the top of a dome, a gigantic dome over that valley, and this could be their way of tracing it. Now, one of the more fascinating things. You can see this from a great distance that this is clearly not a natural structure. You have this perfectly straight ridge that goes through this well. It looks like it might have been a port at one time, since this entry is visible to you and these angles are exactly 90 degrees. We are not sure what this ridge would be, but the fact that it's so straight and continues for such a long distance demonstrates that it can't possibly be natural. There is also a very obvious entry here, and when you consider what's nearby, you can see that it's not part of nature. The water levels may have been very different at that time, and the open mountain we see today may have been covered in water. Now, over here, something very strange occurs. If you look closely at this ridge, there's a very pronounced sharp peak right here. We should be able to see some evidence of a very sharp, pronounced peak in that shadow somewhere. But there isn't even a shadow of a sharp peak here. It appears that someone took great pains to erase it. Did anyone know where the next cable structure is on this mountain? On top of this mountain, there are definitely two structures that they have erased. There's nothing on this ridge that remotely resembles, and when you look at this structure, you see how it's kind of domed, and then it has like 2 points to it. We are aware of the cliffs and the location of this huge, lofty monument with carvings. Considering that there is a smaller pyramid nearby, it appears that this was either the start of a pyramid or that one that had already been completed and collapsed due to some sort of explosion. This pattern can also be seen in South America and Egypt, where larger pyramids always surround smaller ones and form a line. This suggests that there was some sort of issue. We have these mismatched shadows once more. We have this very clean ridge right here, and when we look at the top, we see pointed structures a dome over. If you look closely, it's got all sorts of evidence of things along the top of that ridge, and there's nothing up here. It's smooth and curved, and they're clearly showing structures. If what we're finding here and what we're looking at is just a trick of shadow or a trick of light or trick of the eye. We aren't sure how you'd explain this, especially with the mountaintop shifting completely. I hope you guys like this informative video. So for more upcoming videos, quickly subscribe and hit the bell icon button. Thanks for watching. We will meet in the next video. Bye!